try this, get some oil and some gloves, and get yourself dirty. No.
Hi, and welcome to another episode of FLEETtv. My name is Andrea, and I'm excited to welcome you from the Fleet Science Center and not from my home in La Mesa, because I've missed this place, and I think you have too. Which is why I'm excited that my colleague Ashanti will take you inside on a tour of our amazing exhibition, Illusions.
Hi everyone, and welcome to Illusion. It's not what you see, it's how you see. I'm Ashanti, the exhibition manager here at the Science Center, and one of the teammates that brought this exhibition to life. I'm standing in front of one of the interactives, the Footsteps illusion, developed by Dr. Stuart Anstis, who's right here in San Diego. What we're seeing is contrast and edge information that's actually processed in the primary visual cortex, which is right back here at the very back of the brain. So the primary visual cortex is actually interpreting this visual as fast and slow motion. And that's because of high contrast information that comes from the blue square passing over the white line, and low contrast information that's processing from the blue square passing over the black line. So this high and low contrast information that's alternating is how your brain perceives this illusion as footsteps motion, because there are no footsteps. It's not actually happening. Pretty cool, huh? Welcome to a different part of your brain. We've actually transitioned over into an area where we're going to process visual illusions that use their primary visual cortex, but also an area called V2, V3, and V4. This is kind of mid-level processing. So this illusion asks you to compare and contrast the length of these two lines. So if I ask you which one of these lines is longer, you're probably going to say this line up here. And so what's going on is your brain is interpreting this point up here in the top field of vision and assumes that it's further away. This area down here, wider, lower field of vision, and assuming that it's closer to you. So it's giving you the illusion of depth. But if I were to measure this top line and tell you that it is actually 6 inches long, and then measure this bottom line and tell you that it is also 6 inches long, then you see how your brain is actually interpreting this visual information and telling you that one of these lines is longer than the other, when in actuality, it's not. Your brain is just kind of funny like that. Okay, we've transitioned over into a different area of the brain, as you can see behind it by this overwhelming pink that's everywhere. These are high-level illusions, which means that they require V1, your primary visual cortex, V2, V3, V4, and then we transition over into a new area called the infratemporal cortex. Which also has another area called the fusiform face area. So these are high-level illusions because they use a lot of your brain to process what's actually going on here. So I hope, like me, you're seeing a ton of things looking at you. And you are. So in this area of your brain, you're using all of the low-level brain stuff, and your high-level brain stuff too. You're actually putting together patterns, and you recognize the locations where eyes, noses, and mouths should be. And so because of that, you're probably seeing faces, at least I hope you are, in all of these things. And this is actually a phenomenon called pareidolia. And so as you walk around your home, around your neighborhoods, perhaps as you're traveling in national parks, be on the lookout. Things are looking at you and you're recognizing those patterns, and your brain is doing all of this work, and it's pretty incredible. So remember that, pareidolia. Can you say that 5 times fast? And if you find some pareidolia, make sure to hashtag it pareidolia and send it to us so that we can see the pareidolia that you find in your neighborhood.
Thanks, Ashanti. What an awesome tour. Man, I miss this place so much. But let's take it to Eric, who's going to show us how to make an object disappear. Take it away, Eric.
Hi, folks. My name's Eric, and today I'm at the Fleet Science Center talking to you about reflection and refraction. You can see here we have a beaker of oil. But do we really know what's inside? Let's take a look. It's a little messy, but I can find things in here that you probably didn't even know was in here. Another beaker? Another beaker? What? And more beakers. If I can get them out. Yep. Number 4 and number 5. Why couldn't we see the beakers? It has to do with refraction, which is how fast light travels through the air. And once it hits the oil, it slows down. The reason we don't see the beakers is because of the refractive index. The cool thing about glass and oil is that they both have the same speed limit for light. So the reason we don't see the beakers at first is because the speed limit is the same for both the oil and the glass. I hope you all enjoyed this experiment. Go home and try it for yourselves. Make sure you wear some gloves because it gets a little messy. Signing off, we'll see you next time.
Eric, that was awesome. You're a super magician. And now let's kick it over to Horacio, who says he can make us laugh.
Hi, this is Horacio here at the Fleet in my office. What do you call a successful mirage? An optimal illusion.
And that funny note concludes another Fleet TV episode. Thank you for joining us today. Make sure to follow us on all our social media channels and tell your friends how much fun you have today. And I'm looking forward to seeing you again next week.